Today we are starting on the double angle formula of 17e. So we've already learned about the compound angle formula. So I'm just going to show you where these formulas come from by using the compound formulas that we've already derived earlier. So in the compound formulas we were using the symbols alpha and beta, but we are going to be using theta in these formulas. Now, if I am trying to find the double angle sine 2 theta, that's what double angle means. It means I want double of an angle. Okay, sine of 2 theta or cos of 2 theta or tan of 2 theta. They are the double angle formula that we're trying to derive. Now 2 theta would obviously be theta plus theta. Okay, so using the compound formulas from last lesson, to expand that out would be sine of the first, cos of the second, plus cos of the first, sine of the second. That's the compound angle formula. But because they are both thetas, you can see that for each of those we have sine theta, cos theta. And it's in a different order, but we have sine theta, cos theta for this second term as well. So really, we have just got two lots of sine theta, cos theta. And that's it. That is the double angle formula for sine 2 theta. Sine 2 theta equals 2 sine theta, cos theta. Okay, we use the same process, that's what it says here, use the same process to get the expansions of cos 2 theta and tan 2 theta. So if I want to know cos 2 theta, I write that as cos theta plus theta. Using the expansion, the compound formulas that we learnt last lesson, we would have cos of the first, cos of the second, minus sine of the first, sine of the second. Now, cos times cos is actually cos squared, and sine times sine is sine squared. So we get this first formula here. Cos of 2 theta equals cos squared theta minus sine squared theta. Now, cos 2 theta is different to the other two formulas in that there's 3 different ways that we frequently see this formula. So I've just shown you the first one. To get the other two formulas, all you are doing is using the triad, the Pythagorean triad, sine squared theta plus cos squared theta is equal to 1. So to get to the second formula from that first one, I'm trying to eliminate the sine. So let's rearrange this identity over here, and I would say sine squared theta is equal to 1 minus cos squared theta. Okay, and I would sub this 1 minus cos squared theta in for the sine squared theta. Let's give that a go. So that's going to give us cos 2 theta equals cos squared theta minus, now don't forget that minus will expand through, minus 1, and the minus will become a plus cos squared theta. So when I collect up, I have some like terms here. Cos squared theta plus another cos squared theta is 2 cos squared thetas minus 1. And there is that second formula. To get to the third formula, I won't do it all again, but again I would start with this identity, but I want to eliminate the cos this time. So I would get the cos by itself and I would substitute that in, and I end up with this third formula. Okay, next, the tan formula. To get tan of 2 theta, we start by writing that as tan theta plus theta, and we use our compound angle formula to expand it. The formula is tan of the first plus tan of the second over 1 minus tan the first, tan the second. Now tan plus tan on the top will make 2 tan, and tan times tan on the bottom will make the tan squared, so 1 minus tan squared. And this is our double angle formula for tan. Okay, so you now have a bunch more formulas that you need to be able to use, all the ones in those boxes there. You don't need to be able to derive them, but if I'm perfectly honest, these ones in here, it can be easier if you remember the first one and you can derive the other two if you need them by rearranging like I've shown you. Alright, to the questions. Example number 1. It says, expand cos of theta plus 2 alpha. At the moment, that is just a normal compound angle expansion. So let's, using our compound angle formula that hopefully you've got there near you somewhere where you can look at, to expand that, you have cos of the first thing in the bracket, which is theta, times cos of the second thing in the bracket, which is 2 alpha. Then the formula has a minus sign, and it is sine of the first thing in the bracket, so sine theta, and sine of the second thing in the bracket, 2 alpha. Okay, so I've expanded with my compound angle formula, but I can expand further because I have got these double angles in here. So I can use my double angle formulas to keep expanding. So for my second line, the cos 2 alpha. Now remember, the cos is the one that I have choices for. I have 3 different things that I could substitute in for that. I'm going to substitute in the first one, okay? So the first one up here, the cos theta will stay at the front. The cos 2 alpha, I'm just using alpha instead of a theta here. I'm going to be using that expansion, that cos 2 theta equals cos squared theta minus sine squared theta. So cos 2 alpha is going to be cos squared alpha minus sine squared alpha. Okay, then continuing with the rest of my expansion, minus sine theta, and then sine 2 alpha, another double angle. So sine 2 alpha, there's only one option up here, becomes 2 sine theta cos theta, or in this case I'm using alpha, so it will become 2 sine alpha cos alpha. Okay, now the goal is to expand, so we can still expand further from there. So cos times cos squared would, well, actually, because they're theta and alpha, we can't put those together. We'll just have to put them next to each other. So it'll be cos theta times cos squared alpha. They just have to sit next to each other. Minus cos theta is multiplied with the sine squared alpha. Then, expanding the second one, I want to multiply the sine theta into that bracket. None of them can go together, so they will stay as minus 2, because I have that number there, 2, sine theta, sine alpha, cos alpha. Okay, so at the moment that doesn't seem overly useful. It is just practice getting you to use those formulas to help you expand things out. We'll do some more practical questions a little bit later on in the examples. Question 2 is a prove. We want to prove that sine alpha minus cos alpha all squared is equal to 1 minus sine 2 alpha. Now, anytime you do a proof, you want to start with one side and see if you can get to the other. So I'm going to start with the left-hand side. That's the normal way to start. Left-hand side, which is equal to sine alpha minus cos alpha in brackets all squared. Okay, so there's no formulas that we can use yet, but we can expand that bracket. Okay, so expanding in brackets with the squared up there. The short method to expand that would be to times the sine alpha by itself, which would become sine squared alpha. Then you would have double the two terms times together. So that would be minus 2 for doubling, and timesing them together would be sine alpha cos alpha. And finally, to complete the expansion, I need to do the cos alpha times by itself. The minus times the minus will make a plus, and cos alpha times cos alpha makes cos alpha squared. Now, we're trying to get to 1 minus sine alpha. Try to keep an eye on where you're trying to get to because it gives you an idea of how to simplify. The first thing I hope that you will notice is that I have a sine squared alpha plus a cos squared alpha in my expansion. Remember that lovely old rule, sine squared plus cos squared equals 1. So those two things combine together to make a 1, and then I just have the minus 2 sine alpha cos alpha. Alright, so we've got the 1 that we need. Now for this 2 sine alpha part, I've got 2 sine alpha cos alpha. Now sine 2 alpha, that is a double angle. What is my double angle expansion for sine 2 alpha? It is 2 sine, well, it would be alpha cos alpha. And that's exactly what I have. I have 2 sine alpha cos alpha. This thing here is actually the expansion of the double angle for sine. So if I go in reverse of that formula, it will be 1 minus sine of 2 alpha. And that is equal to my right-hand side. Alright, so the proof is done. On to question 3. If sine theta equals 3 over 4 and theta is between 90 and 180 degrees, evaluate each of the following here in surd form, so exact form. Okay, so the between 90 and 180 degrees part, that is telling me what quadrant my angle is in. So I'm going to draw a little diagram. Over here on the side, my all stations to central. We are between the 90 and the 180 degrees, so we have an angle somewhere in here. So I'm going to make my triangle, so draw a line straight down, right angle triangle, and this is going to be my angle theta in that second quadrant. Now it says that sine theta equals 3 over 4. Now remember, sine is opposite over hypotenuse. So that means that I can put the 3 on the opposite side and the 4 on the hypotenuse side. 3 over 4. Now because I have a right angle triangle there, I can use Pythagoras' theorem to find this missing side. So if I call that x for a moment, x is going to be equal to the square root of 4 squared minus 3 squared. So that's 16 minus 9, which is square root of 7. Remember, we have to leave it exact. Okay, so that side for x is the square root of 7. Okay, now to get back to our question, we are trying to find sine 2 theta. Now, we can use our double angle expansion to know that that is the same as 2 sine theta cos theta. Okay, that's the formula, straight from the last page. Okay, now from this diagram that I've drawn, I can work out everything I need to substitute into that diagram. I have the 2 out the front. Sine theta, I'm already told, was 3 over 4, so I can times that by 3 over 4 for the sine theta. But the cos theta I can get from this triangle. Cos theta equals adjacent over hypotenuse, so that's going to be a root 7 over 4. However, there is one more catch. This theta is in the sine quadrant. If I am wanting to do cos of something in the sine quadrant, it is going to be negative. So I need to put a negative sign on that in there. Okay, so now I just want to simplify that and keeping it in exact form. So I could cancel the 2, because that would be on the top, with 2 on the bottom, like that. And then timesing what is left, I have a 3 times a negative root 7, so that would be negative 3 root 7 on the top. And on the bottom, I have 2 times 4, which is 8. That would be my exact answer in third form. Let's try that again for part B. This time I want to know what the exact value of cos 2 theta is. Now, cos is the one that we have 3 choices for the formula. Because we are in the sine quadrant, it will probably make it easier to use the formula that involves sine. That way we don't have to worry about negative signs. Okay, so using the sine version, that would be equal to 1 minus 2 sine squared theta. Okay, now we know what sine theta is. Sine theta is 3 over 4. We don't even need our diagram for that. So we can substitute that straight in. 1 minus 2 sine theta is 3 over 4, and I just need to square that because it's sine squared. Now we just have to calculate it, keeping it exact. So squaring the 3 over 4, squaring the 3 is 9, squaring 4 is 16, and timesing the 2. Well, cancel the 2. Your calculator will do all of this part for you, and we'll leave it as a fraction for you. And you will get 1 minus 9 over 8, or in other words, negative 1/8. And part C. We now want to find tan of 2 theta. Using the tan expansion for the double angle, we have 2 tan theta over 1 minus tan squared theta. Subbing in using my diagram up above here, I need to know what tan theta is. Tan is opposite over adjacent, so it's going to be 3 over root 7. However, because it is in the sine quadrant, it is going to be negative. So we are going to have 2 times by negative 3 over root 7 over 1 minus negative 3 over root 7 squared. Okay, so then we've got, on the top we would times the 2 with the 3, or the negative 3, so that will make negative 6 over root 7. And we are going to divide that by 1 minus, and I want to square this bracket. So squaring the minus will become positive. So 3 squared is 9, and root 7 squared is 7. Okay, I've changed that into divide form, so I didn't have fractions in fractions. Okay, so keep going from there. We still have that negative 6 over root 7. Now we need to subtract 1 minus 9 over 7. Well, that's a 7 over 7 minus 9 over 7, or in other words, negative 2/7. Oh, I need my divide sign. Let me write that again. I'm dividing that by negative 2/7. Now a divide turns into a times if we turn the second fraction upside down. And then we look for cancelling, so I can cancel the 6 by dividing by 2 to get a 3, which cancels off that 2. And multiplying, I get minus 3 times minus 7, so it's a positive 21 over root 7. Now we should rationalize that if we're being very good people, which we are. So we would times by root 7 over root 7, which would give us 21 root 7 over 7. And there is yet more cancelling. 21 divided by 7 is 3. So my final answer, and most simplified answer, is 3 root 7. Phew, that was a bit of working out for that one, wasn't it? All right, on to question 4. Find sine of 2 inverse cos of 4 over 5. just to throw some inverse causes in there for you as well. So remember, when you have this kind of question, you always want to start on the inside and work your way out. So I'm going to start with the inverse cos. I'm going to leave the 2 out, just inverse cos of 4 over 5. And when we did this previously, we started by saying let alpha equals inverse cos of 4 over 5. Okay, then we used our knowledge of inverse functions to rearrange that, and we said, well, instead I could write that as cos alpha equals 4 over 5. Okay, so let's now have a look at what we have left. Where is my pen? I'm going to use blue. So I'm going to use sine 2. Now I've called the inverse cos of 4 over 5, I called that alpha. So I have sine of 2 alpha. Okay, now that's why this is in this section, because there is a double angle. Now I could use my double angle formula to expand that, which would be 2 sine alpha cos alpha. Now I already know the value of cos alpha. Here it is up here, it's 4 over 5. What about the value of sine alpha? Well, if we draw ourselves a little triangle, we can work it out. So over here on the side, here's my right angle triangle. I'm going to put alpha here in this corner. And for starters, I know that cos alpha equals 4 over 5. That means the adjacent, because cos is adjacent over hypotenuse, the adjacent is 4 and the hypotenuse is 5. Now, using Pythagoras' theorem, we could find this missing side. Hopefully you know that 3, 4, 5 is an identity triangle, so that one there is going to have to be a 3. You can use Pythagoras' theorem if you need to. Okay, so now we can sub into this expression we have over here. So we have 2 times by, now sine alpha from my triangle over here, sine is opposite over hypotenuse, which is 3 over 5, times by cos alpha, which we know from here, or we could do it from the triangle, we get the same thing, is 4 over 5. And when you times all that together, we get our exact answer, which is 24 over 25. Okay, last question, question 5, and I had to finish with a good one. We want to find the exact value of tan 22.5 by using the expression for tan 2 theta. So I'm giving you a clue that we know we need to use a double angle to do this question. So we're going to start by saying the angle that I've been given in this question is the 22.5, right? So I'm going to say, let's call that theta. Theta is the 22.5 degrees. Now, interestingly, 2 theta, because this is the double angle, it tells us it's going to be to do with the double angle. 2 theta, what is double 22.5? Well, double 22.5 is actually 45 degrees, which is actually one of my exact values that I can get an exact value for my exact value triangles. So that's actually really handy to use. So then if I go to my expansion for tan 2 theta, tan 2 theta, oh, my pen's on a slow down. Let's try that again. Tan 2 theta equals, the expansion is tan theta over 1 minus tan squared theta. That's the formula. Now, for our question, tan of 2 theta is 45. So that's actually the same as tan 45 equals 2 tan theta over 1 minus tan squared theta. Tan 45, as I said, is one of our exact values. So you hopefully know this one, but if you need the triangles, we've got 45, 45, and it's 1, 1, root 2. So tan of 45 is opposite over adjacent. It's 1 over 1, which is 1. So tan 45 is 1. And that equals 2 tan theta over 1 minus tan squared theta. Now, it might feel like this is actually still quite messy, but that tan theta that is in my expression here, remember theta is my 22.5 degrees. That is what I'm trying to find, because it says find the exact value of tan 22.5 degrees. So the whole rest of my problem here is I need to find out what tan theta is equal to. So let's see if we can make that into a nicer little equation. Let's times the 1 minus tan squared across to the other side. So that would be 1 times by all of that. So 1 minus tan squared theta is equal to 2 tan theta. Now, believe it or not, this is actually a quadratic because we have a tan squared, a tan, and a constant. So let's put them in order. I want my squared term to be positive, so let's move it across to the other side. So tan squared theta, making it positive. Imagine that's going over to the right side. And I already have the positive 2 tan theta there. And I want to move the 1 across as well, so that would become a negative 1. And when everything's on the same side, that's going to be equal to 0. So there is my quadratic. Think of that as being an x squared plus 2x minus 1. I can solve that to find the tan theta using the quadratic formula. So instead of saying x equals minus b plus or minus so on with the formula, it's going to be tan theta equals, and the a, the b, and the c is going to be, a is going to be the 1, that's imaginary here, b is going to be the 2, and c is the negative 1, subbing that into the quadratic formula. So just in case you've forgotten, minus b plus or minus big square root sign b squared minus 4ac over 2a. So subbing those numbers in, I will get minus 2, because b is minus 2, or b is 2, but there's a minus in the formula. Then I have a plus or minus big square root sign b squared, so that's 2 squared minus 4 times a, which is 1, times c, which is negative 1, over 2 times a, which is 2 times 1. I can just leave that as a 2. Simplifying that, now I want the exact value. The question said I want the exact value, so don't go typing that in the calculator and giving me a decimal here. Let's work out what's underneath that square root sign. So we have minus 2 plus or minus 2 squared minus, so minus 4 times minus 1 will make a plus 4. So it's really 4 plus 4, which is 8. So square root of 8 under there. Now square root of 8 is a surd that can actually be simplified. So let's do that. Square root of 8 is the same as root 4 times root 2. And the square root of 4 is 2. So that's 2 root 2 over 2. Now you can see all these 2's here. As long as I can cancel from everywhere, I can divide everything by 2. So that means I'm going to get a negative 1 dividing that by 2, plus or minus dividing that 2 away means I'll just get root 2, and I've cancelled off the 2 on the bottom. So I have found that tan theta is equal to minus 1 plus or minus root 2. That's actually 2 solutions, remember, because of that plus or minus. Which one is the solution that I want? So remember, all of this comes down to, I'm trying to find the exact value of tan 22.5 degrees. Now tan 22.5 degrees is an acute angle. That's in the first quadrant, which means tan of any angle in that first quadrant should be positive. Okay, so which one of these solutions here is positive? It's going to be the negative 1 plus root 2 would give you a positive solution. Negative 1 minus root 2 would be obviously negative. Okay, so you can put a little note there to remind yourself that that is because, B-E-C-A-U-S-E, make sure I can spell, tan 22.5 must be greater than 0 because it's in the first quadrant. All right, so that's it for today. You've got your questions there to do. Let me know if you need any help.